In this equation, we can look and see that neither the x's nor the y's have the same number in front of them, so we're going to need to alter both equations. Now, it doesn't matter if you choose the x or the y, neither of them will be any easier than the other. In this case, I'm going to choose the x, so I'm going to multiply the bottom equation by 5 and the top equation by 3. Now, what I want to check before I start, 3 times 5 is 15x. 5 times 3 is also 15x. Remember that I want one of the x's to have a negative sign so that they cancel out. So what I'm going to do is add a negative in front of the 5, because I know that negative 5 times 3 is negative 15, and then my x's would cancel out. So when I distribute the 3 into the top equation, I'm going to end up with 15x plus 15y equals 15. When I distribute the negative 5 into the bottom equation, I'm going to end up with negative 15x minus 10y equals negative 35. Now that my x's have the same number in front of them with opposite signs, I can combine them. And I know that the x's will cancel out of the equation because 15 take away 15 is 0 x's. 15 y's minus 10 of them is 5 y's. And 15 minus 35 is negative 20. To finish solving for y, we divide both sides by 5 and find that y equals negative 4. Now we're going to go back and plug negative 4 into one of the equations and solve for x. I'm going to choose the top equation. I'll rewrite it as 5x plus 5 times negative 4 equals 5. It is important that if you found out what y is in the first step, you make sure you're actually changing y in the second step. You don't want to get confused and change the wrong letter, or you'll get the wrong answer. 5 times negative 4 turns into negative 20. So our new problem is 5x minus 20 equals 5. This is a two-step equation. We're going to move the 20 over first and then divide by 5. 5x equals 5 plus 20, which is 25. And when we divide by 5, we'll find that x equals 5. So our final solution written as a coordinate pair, x is 5 and y is negative 4.